In the last video, Miss Glenn explained that we need two different arrays to hold two different facts about every single location. Every single location has a card in it, and we need to know which card number is it. And so that's going to be in an array that I think it makes sense to call cards. This is an example of what cards might look like after you've initialized it by filling it with pairs of unique numbers. But as you know, the game doesn't display that all the cards face up all the time. Then it wouldn't be an interesting game. The cards stay face down, and then as you get matching pairs, some of the pairs are going to remain face up and others will stay face down. So there's a second piece of information we need to know about every location, and that is that card right now face up or face down? We can't save that same piece of information, or at least not easily, inside this array, because here we already have a meaning for every number. The meaning is just what card is actually there. So one way of tackling this problem is to have a second array. I'm going to call it the face-up array, and we'll have the convention that 0 means that a card is not face-up. That means it's face down. And 1 means that a card is face-up. One really important way we're going to need to modify the framework is to decide what the user actually sees. We need to use information from both arrays. Right now, see, this is a self-test. Which card numbers do you think the user should be able to see if this is what numbers are in the grid right now? So I see there's some 1s here, so that means that the user should be able to see the cards 8, 8 be face up. All the rest of the cards are face down except for these two, and these correspond to the same locations as this set of 2s. So the user is going to see some 2s face up and some 8s face up. But the problem is, how do we get our framework to reflect that? Because right now our framework just has one grid, and every single number in the grid will get displayed either as a color or an image. It's not used to seeing two different grids like this. Let me ask you another question. So in a minute after we fix this display, we're going to start thinking about what it means to make a move in the game. The question is, when the player makes a move in the game, are we going to be changing numbers in the cards grid or in the face-up grid, or both? When I make a move, which of the grids do I need to change the numbers inside of? If you want to, you can pause the video. The answer is we are never going to touch the cards array. You initialize it at the very beginning of the game, but if you think about how card matching works, you never change the locations of cards once they're put down. All you do is you flip them over or not. So we're never going to change this grid at all. We're only going to switch 0s and 1s in the face-up grid to keep track of which cards are face-up and which aren't. So let's get into the pseudocode a little bit. This is more or less the blank framework. This is the beginning template as you were given it. Following Miss Glenn's pseudocode, we have a 2D int array, except I'm going to name mine cards. And then we're going to create another private 2D int array, and I'm going to call that faceUp. And then inside the constructor, I've renamed grid to be cards, so let's name this cards. And just like I need to create the cards array, you need to create the faceUp array. Let's type that. Create faceUp array to be the same size as the cards array. We no longer need a current player in the game because it's more of a puzzle, not a game. There aren't two players, there's just one player. We'll come back to the move method in a minute, but for the moment, the important thing is we need to look at we need to look at getGrid and also isInGrid. So you might not have thought about this getGrid before because it's not a method that you knew that you were using. But if we look at how the game actually displays what's on your game board, it uses this method to see what it should be displaying. So let's go over to the runner. Let's do the run graphical game here. Make the font a little bit larger. So here we are inside the draw method. So this line of code right here is also in yours. This is where we ask the display to draw a grid. But how does it know what grid we want to draw? The answer is it comes from the previous line. So we ask the game to give us the int array that we should be drawing. We save it here, and then we tell the display to actually display it. And the display is what knows how to interpret each of the numbers. So the display looks at the numbers in this grid and decides this square should be blue, or this square should be this particular image. So if we want it to only display certain numbers that corresponds to face-up cards, I think the easiest thing for us to do is we're not actually going to return either one of these arrays. Because if we returned the cards array, it would just display all of the cards face up all the time. And if we returned the face up array, then it wouldn't know what actual different cards there are. It would just know which locations were face up, but when it came time to actually display, is it going to be a blue color or a green color, it wouldn't know because it doesn't have access to this information over here. The solution is we're going to create a completely new array, a third two-dimensional array, that's going to combine information from these two. And this is going to represent what we actually want the display object to show to the user. So the way it's going to work is it's got to be the same size as your original, and you're going to loop over every single location in these arrays. And what's going to happen is if a location in the face-up array equals 1, then you're going to copy the corresponding card number. So here I am at row 0, column 0. I see it's a 1, so I'll copy an 8 to that same location, 0, 0. Then I move over 1, I see a 1, so I'll copy an 8 here. When I see a 0, that means the card isn't visible. So I won't do anything. I'll keep that number 0. So this is what the array should look like when we're done. For all the locations that are 0 in the face-up array, those same locations are going to be 0 in the visible array as a way of indicating that we're going to display a face-down card. But any location that contains a 1, we're going to use the actual card number we want to display in that location for the face-up card. So this would be an example of what the output should look like. So how does this look in the actual code? Let's go back to game board. So here inside getGrid, right now, well, I renamed my grid, but like I was saying, I don't want to return the cards array, and I don't want to return the face up array. Instead, what I want to do is let's make a new array right here. And I don't want to make it up here because the only purpose for this array is so that I can immediately use it inside that method. So because I only need the array inside getGrid, I'm going to create it inside getGrid. So create an array. Here, I'm going to do it in pseudocode for you. So create a int bracket bracket visible array that's the same size as the cards array. Then what you want to do is you want to have that pattern where you loop over all the locations. For R, loops over all rows, and then for C, loops over all columns. And then let's think about what we wanted to do. We wanted to check if location RC is visible. And if that location is visible, then set location RC in the visible array to be the number at location RC in the cards array. So we want to copy the card number at the location we're looking at right now into the visibility array at the same location. And so hopefully this pseudocode describes the process that I was trying to depict here graphically. And then, of course, your last step is you need to return the visible array, not the face-up array. I'm gonna keep it as face-up right now just because we don't want to have a broken program. But as soon as you write this, you should replace that return value. Okay, let's see. Let's fix this, because I always like to fix all the compile time problems. It makes me uncomfortable to have them lurking unlooked at. So remember the isInGrid method. The whole purpose is to say whether or not this location is in the grid. We have 3 grids now. So what should we do? So one thing you could do is you could pass the grid as an input that you want it to look at. So we could add an input here called grid. And now when someone runs the isInGrid method, they'll tell you, here's the grid I want to know about, and here's the location. And I want to check, is this location inside of this particular grid? So that would work just fine. A different thing you could do is you could realize that all 3 of these grids are actually the same size. So it doesn't matter which one you choose, just choose one of them. And then your method will still work for all the others. I would say from a design perspective, probably the first solution that I used is more flexible and would be considered better design. But the second solution for beginners is probably easier to work with. So you always want to make sure that you test the methods you're writing as you write them, immediately after. So don't wait till the end to test. So here I am in GameBoard. I went ahead and in getGrid, I said return cards. So you should do that. And you can actually test to see if you're initializing your cards array correctly. Are you actually filling it with pairs of cards? So here I'm going to run, and what you want to look for is you want to see, do you see pairs of unique colors? So I see 2 reds, 2 blues, 2 yellows, and I see 1 gray. So that's a problem, and it's a problem for 2 reasons. First, there isn't a matching one, but the second problem is gray actually means there's a 0 there, and you shouldn't have any zeros at all in your array, because 0 means empty space, and we want the array to be full of cards. The other thing I'm noticing is the reason that there isn't a partner for this one is because I have an odd number of locations. So you should go ahead and change your code so that it's a 4x4 grid or any even number, so an even number by even number. And then double check to make sure that you have pairs of values and that there are no gray values. Okay, so I made some changes. So now I've got a 4x4 grid. I see pairs of randomly assigned values, but I still have a pair of gray values, and so you should also check for that. Here you see I'm testing after I finished writing my code to return the visible array out of getGrid. And even though I know that there are numbers in here, we don't see them because all the cards are face down right now. Notice also that in my GameBoard constructor, don't forget to actually create your face-up array. And you don't have to fill it with anything because we want it to start out full of zeros, but it already starts out full of zeros. In day 2, we'll have a video where you can start thinking about every single time you click on the grid. See, it knows I'm clicking on the grid, but as you click on the grid, it should turn over a card, and then it should turn over the same card, and then hide them both if it's not a match.